All right. Good morning, everyone. My name is Billy Donovan, and I'm a sales engineer here at Long's Littleton office. Before we get started with today's presentation, we have an exciting announcement. Long is now the exclusive representative for American Air Filter, also known as AAF Flanders, for the state of Colorado and Wyoming. Having personally worked as an air filter rep prior to joining Long, I'm thrilled about this new partnership. AAF has been a pioneer in air filtration for over a century. They have a very comprehensive product offering and some truly innovative solutions. So with that, let me introduce today's speaker, Don Largent. Don is the Director of High Purity Product Management for AAF, and he'll be presenting on AAF's groundbreaking HEPA media, MEGAcel 2. So Don, take it from here.
All right, thank you, Billy. Appreciate that. Welcome, everybody. Thanks for taking time out of your morning. We'll get started right away. So we're going to talk about some HEPA technology that you may not be aware of, MEGAcel. And the agenda, we're going to basically cover the what is MEGAcel HEPA media technology, the why. The MEGAcel panel filters is what we're going to focus on for this content, but there are box HEPAs as well, and there's a brief introduction to that, I think, towards the end of the presentation, and then why it's important, the value proposition. So you might be familiar with membrane technology as it's related to air filtration. It has been used since the early to mid 90s, primarily in the semicon and microelectronics and aerospace industries. Basically, it's a single layer membrane, but it was looked at in the life sciences and the pharmaceutical arenas as well. However, due to the validation requirements, primarily using an oil aerosol challenge, PAO, the single layer membranes were not suitable. They would wet out. The pressure drop would go through the roof spike. Obviously, not suitable for fit for use. But because of the properties this membrane technology provided, which made it interesting to the life sciences industry. It's very durable. Anyone familiar with glass media knows how delicate that media is. That's why we do the validation testing, right? To make sure that we don't have any damage causing pinhole leaks or even greater bypass. One of the other benefits too is that this membrane technology offers about half the pressure drop of glass, which translates directly into energy savings, and we'll touch on that later. And then some of the other aspects that aren't really all that salient with respect to life sciences, but can be in certain applications, especially in the semiconductor and chip manufacturing industry. It's boron free and low off gassing, so less pollutants and potential contaminants for those applications. But that carries over to the MEGAcel technology we're talking about today for life sciences. So as you can see at the top of these two columns with the red banners, MEGAcel ME, that's for microelectronics. That's your again, the traditional quotes, single layer membrane. The MEGAcel, what we're just calling MEGAcel, has actually been around since about 2012 when it was initially developed. It is a dual layer membrane geometry and configuration, and I'll show you what that looks like here in the next couple slides. It was designed specifically for the life sciences and pharmaceutical applications, where an oil aerosol challenge agent is necessary to do the validation, either on an annual basis or every 6 months, depending on how critical that occupied space happens to be. Again, has all those same properties: extreme durability, half the pressure drop, which translates directly into energy savings, and then obviously it's rather inert, which we'll talk about as well. So no worries about contamination downstream within the occupied space.
Hey, Don, sorry to interrupt.
Yes, sir.
Can you check that your screen sharing is on? Some people are reporting that they cannot see the content.
Screen sharing is on. I've got the red border. It should be presenting. So
I see it. I see the screen.
not sure what I can do from my end to resolve that for others.
No worries. Let's just continue.
I'll shut my camera off. Maybe it's a bandwidth issue, and maybe that'll help. So MEGAcel 2 media in detail. What we have here is 2 electron microscope images. One on the left, they're both the same magnification, about 10,000 times. The left side is the membrane. On the right side is your traditional glass HEPA media. And as you can see, the fibrils or the fibers for the membrane are much thinner, and there's more of them with respect to the glass. So obviously our pore size is a little different, but even more important, because the fibrils are so much thinner with the membrane, basically we get a slipstream effect with the airflow. So a lot less resistance to the air. This is how we're getting that half the pressure drop through that media. Now, because of the physics of the way particulates captured, submicron particles, the membrane material is also a lot thinner than your traditional glass media, and ergo, because there's so many fibers, you got better chance of those submicron particles impacting and being captured on those fibrils as well, which is how you get the HEPA efficiency. But just food for thought, the MEGAcel media has about 100 million pores per square centimeter, and about 2,000 pores will fit on the top of a ballpoint pen. So just kind of gives you the scope of what we're dealing with here. Again, this is at 10,000 times magnification. So again, some micro scanning electron microscope images here. Basically, we have the membrane on the left-hand side oriented as if the air would be flowing from left to right. So there are 2 membrane layers, very thin in the middle, sandwiched with scrim material on the air entering side and air leaving side. That's primarily to give it structural rigidity. Those thin membrane layers aren't very structurally sound, so this gives us the ability to pleat the media into a form that we're familiar with respect to a filter, a pleated filter. So air is going from left to right. It is a directional filter, so if you do put it in backwards or specify it backwards, you will get the initial efficiency, but you're going to compromise the life of the product potentially, and that's because the first layer has a lower fibril density, bigger pore, larger pore size, or effective pore size, and obviously the second layer is a little bit denser fibrils, and this allows for a bit of depth filtration, but also this geometry, this special blend and how this is laid out also allows for the oil aerosol compatibility. That said, you may hear in the marketplace some individuals that aren't happy that we have this technology try to muddy the waters and refer to traditional membrane technology. This is not your traditional membrane. Again, the traditional membrane is single layer, specific to semicon, micro, and aerospace applications, where an oil aerosol cannot be utilized because of the products that they're manufacturing in the occupied space. The MEGAcel for life sciences is a dual layer membrane technology. So everyone that's familiar with handling HEPA filters knows how easy it is to damage them. You usually see the thumbprints in the middle of the panel filter when someone tried to lift it up over their head. We've gone out and tested this media in a manner of ways, some which aren't typically used in the air filtration industry. Specifically the one in the middle there, that great 100,000 times greater abrasion resistance. That's basically a textile test, but basically this is how resistant it is to someone brushing up on the media. Again, highly durable, and this little video over here will kind of demonstrate that. Anyone familiar with the validation process knows that's an aerosol photometer used for validating HEPA filtration systems. As you can see, the ambient environment's somewhat dirty, goes to the HEPA filter, there's clean air coming through there, hits it with a hammer. You do that with a glass HEPA, and you've got a baseball, softball size hole through the media, and obviously it's not going to pass a certification test. This media, you can actually hit it with a with a mallet like he just did, and it's not going to damage the media and fail a test. Pretty much, you basically would have to maliciously want to damage this media to get it to not pass a validation test. So again, I challenge anyone to take a glass HEPA, do that, and see the results. I can tell you with this MEGAcel technology, I've taken filters out trade shows, and I'll date myself. Anyone that's you can strum it like a washboard, and take it back, put it in an efficiency test rig in the factory, and it's going to pass the test. So we got the durability down. Now we're going to talk about the pressure drop. So what we have here, basically, in this chart, we've got 3 curves. The blue curve is your traditional wet laid glass HEPA media. And then we have an H13 or a 4.9s, and then also an H14 MEGAcel media, represented by the red and the red and the I guess that's a greenish tan line. But this is just to show that over the over the face velocities of this media up to 100 feet per minute, the resistance curve, you can see the delta between the resistance between the glass media and the MEGAcel media. Basically, the MEGAcel media is performing about half the resistance of the glass. And I wanted to show this too because with the H14, even though there is a slight pressure drop penalty with respect to the H13 or the 4.9s MEGAcel, it's a very small difference. You could actually start using H14, get that additional filtration protection for your facility, for your occupied space, and still be at roughly half the pressure drop of glass. So you could realize the durability, obviously, but get the energy savings and increase your filtration efficacy by moving over to this technology. Obviously, in the life sciences environment and applications, the validation testing comes into play. How does this media respond to the validation testing, oil aerosol challenges in that environment? Typically, that's used either a cold Laskin PAO or a thermally generated PAO. The cold Laskin, just for your awareness, I used to sell those products prior to my tenure at AAF. Been with AAF for about 7 years now, but prior to that, for over a decade, I sold the aerosol generators and photometers. Essentially, you want somewhere between 10 and 30 micrograms per liter on average. I mean, that's where we usually shot for. So 15 micrograms per liter over the course of an hour. That's usually when you're testing discrete filters. You're never going to test a discrete filter for 60 straight minutes. It's just not going to happen. But over that time, you can see the 2-inch glass, a 4-inch glass in this case for that green tannish line, and then a 2-inch MEGAcel filter over that same period, being subjected to the same aerosol. And you can see that the 2-inch MEGAcel outperforms the 4-inch glass. So I show this just to point out that if you do have applications with 4-inch glass today, you could replace those with a 2-inch MEGAcel too, and the system would perform just as expected. And then you would get the robustness of the filters. Realize that aspect. On the right-hand side, it's a thermally generated PAO. 35 micrograms per liter, so a little higher concentration, but this is typically your plenum arrangement where you're challenging multiple filters at the same time. It can take a little bit longer because you're exposing all the filters throughout throughout the testing. So while you're testing the first filter, all the rest of the filters are being subjected to the aerosol. So here we did it for 3 hours. Again, you see a little bit of a pressure development curve for both the glass and the MEGAcel 2 filter, but again, that pressure development curve, the differentials pretty much comparable throughout the entire loading process. And then simulating a lifetime exposure test. So we did this based on the most critical spaces, your grade A, grade B spaces, where you may be testing every 6 months, twice a year. And we did 1 hour interval tests, just like we did with the Laskin nozzle on the prior slide, 15 micrograms per liter, and we just repeated that over and over and over again. So in this case, At 20 cycles, that's going to be, you're annually tested, obviously 20 cycles, 20 years. If you're testing every 6 months and your more critical applications twice a year, that's like a 10-year life expectancy. We took this out to 30 cycles, no issues whatsoever. So you see that pressure development curve holds true throughout the life of the product. And these life science applications, we also have other things to consider. Obviously, we're using cleaning agents and some pretty harsh decontamination agents, depending on the application. Based on the technology that we're using in our MEGAcel filters with respect to the traditional microglass, obviously, this is how it would stack up. So in the life sciences arena with the MEGAcel, you get the robustness. That's the Achilles heel of the glass, is the fragility, but also the pressure drop, which we don't show on here. But with respect to the semicon micro, again, the traditional single layer membrane, when it comes to oil or liquid aerosols, very, very poor compatibility there, where with respect to the MEGAcel for life sciences, no issues whatsoever. And again, listing out some of those cleaning agents and decontamination agents that you would typically see in these environments, from acetone to isopropyl to your spore cleanse, which is your parasitic acid and acetic acid, hydrogen peroxide, etc. Completely inert and no issue whatsoever. As a matter of fact, it performs better than the traditional glass at very extreme conditions. We did some immersion testing that proved that out. When it comes to the pressure drop translates directly into energy savings. If you do the total cost of ownership, and when I say total cost, all we are looking at is the initial cost of the filter and the energy cost as a result of the filter. We aren't looking at the spares that you keep on hand, the potential for reducing your mechanicals if it's a ground up new installation because of the lower pressure drop. But as you can see, at least in this example, I know everyone's energy costs are different depending on where you're at. Here we used somewhat high energy cost of 13 cents per kilowatt hour. If you happen to be in Puerto Rico, it's more like 24 cents per kilowatt hour. Fan efficiency of 50%, which we've got studies to show that that's probably even a little high based on the systems that have been evaluated. But a service life of 7 years, this one's going to pay for itself in about 2 years, so it'll pay for itself at least 3 times over for the life of the product. Based on these budgetary numbers, obviously, everyone's situation is unique. We can run these numbers for you. Work with Long and Associates to get that information to you so you can evaluate that. But again, this is just purely the initial cost differential of the filter, which in this case was about an extra $100 or an extra 25% based off above the glass, and then how that energy savings will pay for itself over the life of the filter a couple times over. One thing that we don't consider when we talk about pressure drop sometimes is the housing within which it goes into. So I just wanted to show this with an AAF Astrocell 1 damper, or Astrocell 1 supply hood with an ESD damper, energy savings damper. We can add some more savings on the resistance and translating into direct end user costs. I did stack the deck on this one, and in full transparency, the first 2 housings are using not just different dampers, but they're also using the glass media. But this is just to show that using those 2 in unison, you can translate into energy annual savings costs anywhere from $65 per box up to $180, depending on the configuration. So just in summary, I can say without question, coming from the testing world and into AAF 7 years ago, the MEGAcel technology, without question, is the highest performing HEPA technology out there, hands down, and it'll provide the highest risk mitigation at the lowest total cost of ownership. And we've been, like I said, we've been selling this for the better part of a little over a decade now, and I'm sure you recognize most of those names. All of these companies are utilizing MEGAcel technology somewhere in their facilities around the world, and continues to grow year after year. So with that, I will hand it back over to Billy. Appreciate your time.
Thank you very much, Don. If you have any questions on MEGAcel 2 or any of AAF's other solutions, please don't hesitate to reach out to your Long rep. Please join us next week where Andrew Schmidt will be discussing Hero Pro cloud-based controls for Daikin VRV systems. Thank you again for joining, and we'll see you next week.